All right, today we're jumping into what is basically a cosmic detective story. Our suspects? They're these tiny, microscopic specks of space dust that have been traveling for billions of years. And our mission? Well, it's to unlock the ancient secrets hidden inside them without accidentally destroying all the evidence.
So, that's the central mystery, right? These little particles are like tiny time capsules, packed with information from the very birth of our solar system, 4.5 billion years ago. But how in the world do you open a time capsule that's more fragile than you can even imagine?
These amazing little artifacts are called interplanetary dust particles, or IDPs for short. They've just been drifting through space for eons, and along the way, they've been collecting clues about everything: the chemical makeup of ancient comets, even radiation from our own sun when it was young. They are, and I'm not exaggerating, some of the most scientifically valuable materials we can possibly get our hands on.
But like any good detective story, there's a problem, a big one. See, to study these particles, we have to actually collect them. And the only way to do that is to wait for them to fall to Earth. The thing is, their journey down through our atmosphere is, let's just say it's anything but gentle. And the scientists who studied this really put it best. This fiery entry is a huge unknown. As one of these particles just plummets through the atmosphere, friction heats it up to insane temperatures. So it begs the question, are we studying an ancient, pristine artifact, or are we just looking at a melted blob?
And here's the heart of the issue. Out in space, this dust is a perfect record. But by the time we get it here on Earth, its minerals could be totally altered, its chemical data could be changed, and these crucial little records called solar flare tracks, they might be completely erased. The crime scene, in other words, is getting contaminated before we can even start our investigation.
So how do you solve a problem like that? I mean, if you can't observe the event itself, you do the next best thing. You recreate it. And this is where the scientists got incredibly clever. They decided to build a special kind of oven that could perfectly mimic that flash heating a tiny particle goes through as it screams through our atmosphere. It's a really brilliant way to control all the variables and see exactly what happens to the evidence at different temperatures. Their process was just so meticulous. First, they needed some test subjects, so they crushed up tiny bits of well-studied meteorites. Then, they put these little fragments onto a grid, a really tiny one that can fit inside a microscope. Now, the key part is step 3, a pulse heat that lasts for just a few seconds, just like that fiery atmospheric entry. And finally, they look at the aftermath with a super powerful electron microscope to see what changed. Now, you can't just go and destroy these actual priceless IDPs in a lab test, right? That would defeat the whole purpose. So they use the next best thing, analogs from famous meteorites like Murchison and Orgeal. These have a very similar makeup. They're made of the same primitive, ancient material from the early solar system. This gave them a really reliable baseline to check their results against. Okay, so with the experiment up and running, the scientists were basically on a stakeout. They were watching for very specific changes, looking for these telltale signs that would only appear at certain temperatures. What they were doing, in essence, was building and calibrating a cosmic thermometer. And guess what? They found them. 2 distinct, unmistakable markers that could tell them exactly how hot a particle had gotten. This was the breakthrough, the absolute key to being able to read the history of any dust particle they found from that point on. The first clue is all about what disappears. You can think of it like a memory being totally wiped clean by the intense heat. At 600 degrees Celsius, they found that solar flare tracks, which are literally tiny tunnels bored into the minerals by particles from the sun, are completely erased. Just poof, they're gone. So if you find a dust particle and it still has these tracks, you know for a fact it never got that hot. It's a definite temperature ceiling.
Now, the second clue was even more interesting. This one wasn't about what disappeared, but about what got created in all that heat.
Once they cranked the heat up past 1,000 degrees Celsius, something really dramatic happened. The material started to melt and then reform into these tiny, regular little crystalline droplets. In the lab, these droplets were, and this is their word, ubiquitous. They were absolutely everywhere. This became the telltale signature of really extreme heating. So, our detectives finally had their clues. They knew the fingerprints of heat. The final step was to go back to the real evidence, those dust particles collected from the stratosphere, and check to see if these temperature markers were there.
So what did they find when they looked at the real deal? Well, were the solar flare tracks erased? Yeah, sometimes.
So that told them that some particles definitely got hotter than 600 degrees. But what about those telltale droplets, the smoking gun for that extreme 1,000-degree heat? They were seen only very, very rarely.
And that brings us to the verdict. The fact that those unique 1,000-degree droplets are almost never found is the final crucial clue. It means most of these precious particles actually survive their fiery plunge without getting cooked into oblivion. The evidence is not nearly as contaminated as we feared. Our cosmic time capsules are arriving with their secrets intact. It's just an incredible piece of scientific detective work. But it leaves you with this final thought, doesn't it? All of this ingenuity, all of this incredible work was to understand the journey of a single, tiny speck of dust. It really makes you wonder, as we start looking to other planets and other solar systems, what incredible new methods will we have to invent to read the epic stories that are still out there, just waiting for us?